Good morning! I'm Dr. Huang. Today, I'm going to teach you some very important skills to solve problems that include ideal gas law and chemical reactions. Before you start to look for a solution for a problem, it is extremely important to read the question carefully and rewrite the important information. When I say the important information, I mean chemical equation, numbers with units, and what we are looking for. To a chemist, when you are provided a problem, the first thing that will catch your eyes probably is the chemical equation. If you see a chemical equation, immediately copy it down. Then you read the problem and search for the numbers and units and what we are looking for, and put them down into appropriate places close to the chemical equation. Let's read the problem from the beginning. Both Jack Charles and Joseph Louis Guy Lussac were avid balloonists. In his original flight in 1783, Charles used a balloon that contained approximately 31,150 liters of hydrogen. I will put down 31,150 liters below H2 under the chemical equation, because this number and unit is for H2 gas. Then let's continue to read. He generated the hydrogen using the reaction between iron and hydrochloric acid. How many kilograms of iron? This is what we are looking for. I will put down kilogram of iron below Fe under the chemical equation. I also put down a question mark to indicate this is what we are looking for. Then let's continue to read. How many kilograms of iron is needed to produce this volume of H2 if the temperature is 22 degrees Celsius? This temperature is the temperature of H2 gas. I put down 22 degrees Celsius below H2. It is another good habit to assign an appropriate symbol to the numbers with units. This is the volume, so we assign V equal to 31,150 liters. And the second one is temperature. We put down T equal to. The benefits to put down appropriate symbols to the numbers with units is this will allow us to quickly find out what equation we need to use to do our calculation, because all the equations contain symbols. And it will also help us to identify what is missing. After we finish summarizing the information, let's see what kind of calculation this can be. We are provided the volume and temperature of hydrogen gas, which is a product of this reaction. And we need to calculate the mass of Fe in kilograms. There is only one kind of calculation can allow us to convert from a product into a reactant. It is stoichiometry. But for a typical stoichiometry problem, we need to know the moles of a product. So, in order to finish this calculation, we have to find a way to convert the volume and temperature of hydrogen gas into moles of hydrogen gas. If we know the moles of hydrogen gas, we can use the balanced chemical equation to convert to the moles of Fe. If we calculate the moles of Fe, we can use the molar mass to find out the mass of Fe in grams, and then convert grams to kilograms by using the unit conversions. Then, let's look at the first step. We know the volume, we know the temperature of hydrogen gas. We want to know the moles of hydrogen gas. We probably need the ideal gas law to finish this conversion. However, if we want to use the ideal gas law, we also need to know the pressure of hydrogen gas. Let's read the problem again very carefully. Let's say if we can find the pressure of hydrogen gas. After we read the problem one more time, we still cannot find the pressure of hydrogen gas. But we do have a hint in this problem. Charles used a balloon in his original flight. This person will fly the balloon in the air. So, the pressure of the hydrogen gas inside the balloon should be equal to the pressure of the air outside the balloon. Then, the pressure of the hydrogen gas should be 1 atmospheric pressure, which is the pressure of the air. Now we know the volume, temperature, and pressure. We can use the ideal gas law to convert to the moles of hydrogen gas. Then we follow this path to finish our calculation. We can see here, after our analysis, we turn a complex problem into 3 simpler steps. Step 1, Step 2, and Step 3. The first step is we need to use the ideal gas law. We need to use the algebraic skills we learned from math classes to do a rearrangement. The moles equal to PV divided by RT. All we need to do is we need to plug in the numbers with units. The pressure is 1 atmospheric pressure. The volume is 31.150 liters. R is 0.08206 liter atmospheric pressure over moles and Kelvin. And we need the temperature, but the temperature given is in degrees Celsius. So we need to convert to Kelvin. This can be easily done. We just add 273 to the temperature. In degrees Celsius, we get 295 Kelvin. Then we plug in 295 Kelvin here. Then let's look at the units. Say if they can cancel to give us the unit we are looking for. Atmospheric pressure on top, atmospheric pressure at the bottom. And liter on top and liter at the bottom, they can cancel. Kelvin on top and Kelvin at the bottom, they cancel. The unit we have left is moles. Because we have 4 different chemicals in the same problem, it's better to put down the chemical formula behind the unit, so we will not confuse ourselves. What we need to do next is we plug all the numbers into a calculator. From the calculator, the answer is 1287. Now we get 1287 moles of H2. Then we need to use a conversion factor from the balanced chemical equation to do the conversion from moles of H2 to moles of Fe. This is the typical stoichiometry calculation. So our second step is 1287 moles of Fe. No, sorry, is H2. We need to convert factor from the balanced chemical equation is for every 1 mole of H2, we will need 1 mole of Fe. Mole of H2, mole of H2, they will cancel. The unit we have left is mole of Fe. The math is extremely simple. The answer is 1287 mole of Fe. 1287 mole of Fe. Then we need to do the last step, step 3. We need to convert mole of Fe into kilogram of Fe. We need to use a periodic table to find out the atomic mass of Fe. Here is the periodic table. After we find Fe, we find a number, 55.85. This means for every 1 mole of Fe, it is 55.85 gram of Fe. Remember, we get 1287 mole of Fe from the previous step. Mole of Fe will cancel, mole of Fe will cancel. We will get gram of Fe, but we are looking for kilogram of Fe. So we need to do another step of conversion. From chapter 1, we know that for every kilogram of Fe, it is equal to 1,000 gram of Fe, because the prefix K represents 1,000 or 10 to the third. Gram of Fe and gram of Fe, they will cancel. Then we need to plug all the numbers into a calculator. And the number we get is 71.9 kilogram of Fe. Now we are done. But I want to remind you, during an exam, all I need is what we have on the right side. For what we have on the left side is your analysis. You do not need to show me, but if you do, it's fine. This analysis is a very important step to simplify the problem and to find the solution.